Okay, I think I got confused. I think this is actually part 3. Still section 9.2. Picking up with problem 23. We're supposed to verify that this sum of 1 over n plus 1 converges. Okay, it is telescoping, even though it isn't, like it's in a common denominator form. The terms written out would look like that directly, but to verify it converges that it has a finite sum, you have to bust it apart. This is why we did partial fractions back in section 8.5. So it's two distinct linears. Put the a over n, the b over the other factor. It's already factored for you. Put these terms back together. Again, it's a cross pattern. And then you wind up setting the initial top again equal to that top, which is where I get this equation right here at the bottom. Okay, remember that there were two magic numbers. If you set the bottoms of these to 0, n equals 0 will tell you the a, and negative 1 will tell you the b. So when I use n equals 0, plug n equals 0 into that equation, and I wind up with 1 equals a, the b cancels out, just dies. When I use n equals negative 1, 1 equals b times negative 1 because the a term will die. And so the initial sum here splits as two fractions subtracted. When you write out the terms for n equal 1, you get 1 minus a half, 2, 1/2 minus a third, third minus a fourth, and so on until when you've shown it enough to pick up on the pattern, you always end it with what you were given. I won't draw in the canceled terms. It makes it look even more gibberish than it already does. But if you can see, negative a half, add a half, negative third, second one on one cancels the first on the next one. You're left with the lead 1. The first on the next one down here would be the 1 over n, so you're left with that last minus 1 over n plus 1. When you take the limit on that as n goes to infinity, infinity on the bottom here, that term will go to 0, you're left with 1, and you can conclude that that sum converges by the telescoping series test. We can actually refer to it in that form. Page 605, find the sum of 1 over 2 to the n minus 1 over 3 to the n. These are two geometrics. To make them look more obvious, I rewrote them 1/2 to the n minus 1/3 to the n. Individually on both, the a is 1, its coefficient, the r is a half. On both, each one will have a sum of a over 1 minus r. For the first one, 1 over 1 minus a half. And you'll subtract, and minus 1 over 1 minus a third. Your bottom here, 1 over a half minus 1 over 2/3. They flip around. 1 over a half is 2. 1 over 2/3 is 3/2. 2 minus 3/2 gives you a sum of 1/2. Part 3 is over. We'll pick up with part 4.